The following program is an encore presentation.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
The Big Dipper, the Seven Sisters, Saturn, and Mars. Wonders in the summer night sky are eternal. All week we'll find out what's out there with astronomer Bryan Gaensler, astrophysicist Nathalie Ouellette, aerospace engineer Walter Stoddard, and physics and astronomy professor Matthew Johnson. Tonight, the irresistible view from Earth. That's next on the Agenda in the Summer.
I am so excited for this week because when I was a little kid, and please don't judge me on this, because I almost didn't say this, but when I was a little kid, I wanted to be a witch, then I wanted to be Dracula, and then I wanted to be Sailor Moon. But what was consistent is that I wanted to be an astronaut. And as a kid, I remember looking up into the sky and thinking, whoa. But then when I got older, I think with life and everything, I kind of didn't really think about it. And then now as I've gotten older, I'm in midlife, I'm kind of like looking up in the sky again and having like these big questions like what else is out there? So I'm so glad that we're going to get to learn from all of you over the next week. So I wanted to start with this question. Matthew, I'll start with you. Why are we so fascinated with space?
I think it's in us. So I observe in my son, when he was 3, he loved planets. And it's impossible, I think, for him to conceive of like, what's a planet at 3, but somehow it was something that struck him. And then he went on to memorize the names of all the planets, all the major moons around all the planets, and he would just repeat them. It was like his mantra. Yeah, at 3. It was his mantra, and he would just flip through books about space and planets and talk about it to himself.
What about you, Nathalie?
Yeah, I think it's the mystery of the unknown. I think we often say astronomy is the oldest science. We've been doing it for millennia, and it's because it's quite accessible. You don't really need tools to do it at the start. You just go outside and you look up, and then you wonder, and you have all these questions that come out. And for a long time, we didn't necessarily have access to any answers. We didn't have the tools, we couldn't go up there. And so people build these cultures and these mythologies and these legends all around it. And now we're getting to the point where we have the tools to try to figure out these like big answers to these big questions. So yeah, it's the mystery of it all, I think, for sure.
Yeah, and that excites you now that we have the tools.
Yes, yeah. Of course. Yeah. Now it's fantastic. We're always saying it's a golden age of astronomy right now. There's lots of clashes with culture and science, and I think astronomy, we call it the gateway science too. Like everyone feels excited about astronomy, and we don't necessarily want everyone to be an astronomer, but the little kids, they end up having that curiosity that they carry through if they become a scientist or anything else.
And what about you, Walter? What do you?
Well, I remember when there was, and unfortunately, right, the blackout that made all of Toronto dark.
2003?
Yes, yeah, and it was across the whole seaboard, but people were coming out of their homes saying, what's wrong with the sky? Like there are actual 911 calls, right? Because they looked up and without all of the light pollution, they looked up and went, wow.
They saw stars.
They saw stars, and more stars than they ever thought were there. Right? Because now you can see them because all the lights are out, right? And so I think that's the right response. The right response to life is awe and wonder. And what better than the night sky to bring that out of someone?
And what about you, Bryan?
I think that part of it is that people don't like the idea that we don't know something. Like, I think there's this deep human need to understand things that we don't know. And the challenge is that a lot of things we figure out after a few years. And the universe is probably the thing that's most resistant to figuring it out. And that once you understand one component of the universe, well, there's that part that we don't get. And if we understand that, but that means that doesn't make sense. And so I think part of the appeal, it's the same sort of appeal that people have when there's something that's off the map. It's like, oh, I wonder what's there. Space is obviously this unending map, and we've barely scratched the surface. So I think the idea that it's unknown. Sort of that sort of Star Trek sort of mentality of seeking out new worlds and discovering new things. I mean, space is just the ultimate playground for finding new things.
But what keeps you moving? Because you said you don't know. There's so many things that you don't know, and you're looking for these questions. Do you ever get frustrated and say, "I give up"? Like, what keeps you moving?
We get frustrated
Yeah.
for sure, but yeah, the goal is not to give up. I think that, and this is something that I'm hoping will change over time. People have a tendency to think that science and the scientific process is very linear. It's always moving in one direction, and you're just going breakthrough to breakthrough to breakthrough. But you hit a wall, you have to take 10 steps back, and you have to restart, and it's just part of life and of science. And so that's something that you have to learn as you're becoming a scientist, for sure.
Walter, I see you nodding.
Yeah, not knowing is actually okay. Like, it's okay to not know something and to fail your way to understanding. Like, that is absolutely right. The process of science is discovery and discovering. I love the idea that you discover something and you realize something else is wrong and you have to go back and change it. The persistence on our part is tantamount to learning.
So failure is part of the process, because in a lot of life, failure is not the way we go. We want to avoid failure.
Yes.
Yeah.
You don't. People don't like red X's. Right?
No. But in this instance, it's okay.
Absolutely.
Of course.
Well, it's more than okay. If you're working on some problem and you get the answer pretty quickly and it all makes sense, what the instinct you develop as a scientist is, that was too easy. I bet you somebody else did this 20 or 30 years ago. Where if it's really, really hard, I've developed now this sense, like, if something's really frustrating, I want to give up. That's actually Spidey sense saying, ding, 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 ding. This is actually really interesting. This could be really interesting. If this is hard, it probably means everybody else has given up on it and you should keep going. It doesn't always work out that way, but if something is frustrating, it's probably worth doing.
You're onto something.
Yeah.
I'm super curious as to what drew you all into it. Matthew, I'll start with you.
Yeah, so I dropped out of high school. I wanted to be a fiction writer.
You dropped out of high school?
Yeah, I dropped out of high school. And decided working in a hardware store for the rest of my life probably wasn't going to be great. So I started looking around for what kind of education opportunities I could look into. And I happened upon this great university in Washington State called the Evergreen State College. No grades, no majors, no requirements. Yeah, that sounds great. So I went there. I wanted to be a writer, and I took a bunch of courses on writing. But there was one course that I took that was a combination of science fiction writing and actual science. And that's something I ever took very seriously before. And part of it was calculus. And I saw calculus for the first time in my life. And I don't know what it was, but calculus was the coolest thing I had ever seen.
Not a lot of people.
Awesome.
No,
That is such an awesome response to Kevin.
you know.
I mean, I agree with you, but I wouldn't say it out loud.
I think it's so interesting because it's like we hear a lot of stay in school, but because you dropped out of high school, you were able to then find the path that you were meant to be on.
I think it took the pause for me to know what I wanted to do. I think that was really important for me personally, is the reevaluation period and thinking about what my goals were and what I actually wanted to do was super important. Yeah, but at the end of this map making, I asked my professor, how do I do more calculus? He said, go take a physics course. And then after that, I just loved it.
That's all she wrote.
Yeah.
What about you, Nathalie?
So both my parents are engineers, so we were a very scientific household. I think that I had strong models at home, which was great. But I was always really an observer. I wasn't a tinkerer, or like I didn't break apart machines or try to build them back together. I just loved to quietly sit and watch the clouds or look at rocks. And I sort of fell in love with nature that way. And I still love nature. And nature is something that's it's still, in a world where humans feel like they're in control of a lot of things, I think nature can sometimes really bring us to our knees. And it's something that's much bigger than us. So I like the idea of understanding these physical phenomena that were so much bigger. So I thought, okay, what's really big? All right, can you get bigger than a galaxy smashing into another galaxy? That's pretty big. So since I was 5 years old, I started reading books about space and looking at documentaries.
You were reading books at 5 years old?
Oh, my parents were always bringing me to the library, and I was looking. The pictures were beautiful too. That helped a lot. But yeah, I knew from a really young age that astronomy was something that I wanted to pursue.
And Bryan?
As my wife keeps reminding me, I can never enjoy myself in the moment, because even when I'm doing something I love, I'm thinking about how many minutes, like, this football game has to go, or you know, how many days this vacation has left, and I'm sort of feeling sad that it's going to end. And so it's the same for me whenever I'm reading a book or seeing a film. All I can think about is, this is going to end, and like, then what? Then I'm going to have to do something else. And so when I was young, my parents bought me books. I liked science and facts, and so they bought me books on volcanoes and dinosaurs, and the volcano book was fantastic. But I was always, I mean, I read it over and over again, but I was always sad because you sort of get to the end and you're done. And that's all we know about volcanoes. I could read it again and, you know, that's it. Like, there are just answers to everything. Here's how they work, the end. And then they got me a book on astronomy, a book I still have, and it was totally different from all these other books. Instead of saying, you know, here's how it works, and this is this, and this is this, it said, we don't know anything, and we're probably never going to figure it out. And I thought, oh my gosh, I finally found the book that never ends. I can actually enjoy astronomy and not be thinking about what happens when we've all figured this out. Like, I finally found the film that I can just watch for the rest of my life and not worry about the credits rolling.
That's so interesting. And what do you think it is about you that's the thing that drew you in?
You can sort of get answers to all the things you want, but you don't have to worry about running out of questions. Like, my greatest fear is that at some point someone will say, well done, everyone. We've solved astronomy. Let's turn the lights out. I'll see you at the pub. And that's just never going to happen. And I just feel very reassured that, you know, basically that my employment situation is secure and I'm friends.
Did you love The Never-Ending Story as a child?
The Never-Ending Story. The book and the movie.
God.
I read that book 1,000 times, and I did not want it to end.
Of course.
So that's so interesting. So the unknown is comforting to you.
Yes, that the unknown is comforting to me, because it was a huge shock as a child when I first found out that there were things that nobody knew. Because as a young kid, I think, well, my parents sort of know a lot, and then if they don't know, the teacher will know, and if the teacher doesn't know, it will be in an encyclopedia. And then that astronomy book made me realize there are things that nobody knows, which just blew my mind. I just figured that somewhere someone would know the answer. And then the second, that sort of the 1-2 punch was, not only are there things that nobody knows, but there's this job called scientist or called astronomer, where your job is to find out the things that nobody knows. And that appeal of, maybe one day I will be the first person to figure something out. Like, I thought, oh my gosh, that's what I want to do. And you know, those of us that have done research, that moment when you find out something and you know that nobody else knows this, like, you know, you have to tell everybody, like, you have to, like, publish a paper or go to a conference or announce it or whatever. But just for 5 minutes, I sit there and thinking, this is mine. I'm the only person in the world that knows that. And that's the best feeling in the world.
What about you, Walter?
So I have to credit Mom and Dad.
Yeah.
And my father passed away when I was 12 and a half. Mom, single mom, working as a chemist. And she fed my science habit. Brought home equipment that was being scrapped. So it's like, well, do you know a kid or a school could use it? Oh, yeah, I know a kid. Right?
I think I know someone.
Right, yeah. So she fed my science hunger, which was amazing. And my earliest memory of my dad, and this is weird, right? So if you're, you know, fun fact, at the age of 7, thereabouts, your memory scrambles. So you lose episodic memory, and you remember how to read, how to write, how to ride a bike, but you don't remember the events. The events kind of get all blurry. But I have this event that is crystal clear, and it's the big bowl of cereal that my dad would pour for himself, and I'd sit in his lap, and with binoculars we would watch the skyline being built of Toronto. And like helicopter cranes coming in and finishing it off. And I told my mother, I said, I remember this event. She's like, it wasn't an event. That was every morning of your life for the first 2 years. Wow. It's like, oh, okay, so it's imprinted. And so, of course, the buildings, the helicopters, aerospace engineer. Like, it was built right into the fabric of who I am because of those moments with Dad. And then Mom nurtured it all along.
That is so cool. In a way, it's like you're connected to your dad in a way that you wouldn't be if you didn't have those memories.
That's true.
Yeah.
That's true.
Yeah.
I'm so jealous. I was just mixing shampoo in shampoo bottles. What kind of cool stuff did you get?
Well, I did that too, but I did it with beakers that were from a lab.
Nathalie, what makes Earth so special?
We've not found another planet like it up until now. These Earth 2.0s are sort of like the holy grail in exoplanet research, exoplanets being planets beyond our solar system. So we're not looking for them because we want to move there. We just want to sort of place the Earth in the greater context of the universe. How common is an Earth-like planet? How common would it be for life to develop? And we still haven't found anything that quite fits the bill. Certainly in the solar system, we even have now probes and rovers going to these other places. And the only place where we have concrete evidence that there's life is on Earth right now. So that's quite significant. It also makes the search for alien life very complicated because we only have this one data point. So in searching for alien life, we're searching for Earth-like life. And so maybe there's other kinds of life out there that we're missing because we don't know what to look for. But it's our spaceship. And funnily enough, often people think astronomers are looking outwards, dreaming of going somewhere else. But in my experience, astronomers are some of the most eco-conscious people because we know how fragile the Earth is and that we don't have a backup plan if something goes wrong. So it is very special, and it's essential for humans to take care of it.
That's so interesting you said that. I saw, Bryan, you were nodding when Nathalie was talking.
Yeah, I think that astronomers have often talked about Earth being the Goldilocks planet, or in the Goldilocks zone, in that it's at the right distance from the sun, it's sort of the right size, and it's sort of spinning at the right speed. And I think the more we learn about the universe and about other planets, it's like the intersection of like 50 different Goldilockses, in that like it also has just the right amount of radioactivity, it has like the right sort of magnetic field, it has the right mix of chemical elements. And so, I don't work in the exoplanet field, and hopefully you're more upbeat than me, but when I think about how many different special boxes the Earth ticks, I sort of get a little bit pessimistic that we're ever going to find an Earth 2.
Yeah, I think that there's different camps. I know that people like Carl Sagan or Drake were more optimistic, and they think there are hundreds of billions of planets in just our galaxy alone. So somewhere out there must be something where life could have evolved. But maybe we are just the lucky one planet where everything intersected just at the right moment.
But does that bring up the question of why us? Why do we have that?
So it's sort of like a paradox.
Yeah.
It's us because we are here and we're the only ones who can think about the question. If it wasn't us, we wouldn't be here, so we wouldn't be asking that question. So it sort of leads into each other. It's like a snake eating its own tail kind of thing. Yeah.
So more questions.
Yeah, exactly.
I wanted to show you something. You can probably see it on the monitor. This image was taken in 2015 of an aurora borealis, the northern lights, and it was captured by NASA astronaut Scott Kelly of Expedition 44 on the International Space Station. You can see lines of green, and as we move away from the Earth, bands of red. Auroras, how do they happen? Matthew?
Yeah, so you have solar activity. The sun is not a static object. It's constantly spitting out hot gas, and it goes somewhere. So some of that gas ends up in the vicinity of the Earth. And the Earth has a strong magnetic field. If it didn't, we wouldn't be here talking. That's one of the Goldilocks conditions that Bryan was mentioning. So instead, we get this beautiful light show.
Why the different colors?
So that is the particles from the sun getting bent by the magnetic field and hitting the Earth's atmosphere. And when it hits the atoms in the Earth's atmosphere, it excites them. And so, like neon bulbs, the sky lights up from these atoms being excited in the Earth's atmosphere.
My sister lives in London, Ontario, and I think earlier this year she said she saw one. Why are we seeing them further away from the poles?
Yeah, it's because right now we're having quite a lot of solar activity. So there's different scales. You can look online, and there's like an aurora watch, and there is a delay between when the sun has a storm and when those particles hit. So usually we can actually tell if there's a solar storm that happened, and it's a particular intense one. We can tell that in the next few nights or in the next week or so, the aurora will be particularly intense, and that means that it'll be able to go down to lower latitudes, more south. And so we've been having quite a lot of that.
Why are we having so much solar activity?
So one of the reasons is because the sun is on a cycle. It's on an 11-year cycle, and so we're heading towards a maximum in a year or so. And so the sun gets a little bit more excited and starts spewing out more stuff. It's wonderful. It's not a once-in-a-lifetime kind of thing. It happens quite regularly. But I think one of the wonderful things is now everyone has a really great camera in their pockets, and they can capture that. Some of the long exposures I've seen from iPhones have been wonderful. Yeah. I've yet to see one. I'm keeping my fingers crossed, but it's because of the solar activity.
Okay, this next question is going to sound odd for all of you, but when I found out the answer, I was like, you know that emoji with like the brain?
The brain exploding.
That was my reaction. Walter, where does our moon come from?
And you're asking me.
You can punt it to somebody else if you want.
Yeah. Well, correct me. My understanding is like that's the defining moment when Earth became Earth. Was that collision of the stray, small planetoid thing impacting our planet, and it's a hitchhiker that's stuck around. Is that a good summary? Like went smack, and now it's part of us.
It's sort of, it tore a chunk out of the Earth. We think there was sort of a Mars-sized mini planet that collided with Earth. We call it Theia. And it tore apart a big chunk of the Earth. And you had all this debris around, which ended up coalescing into the moon, which is one of the reasons why there's a lot of similarity between the kinds of rocks on the Earth and the kinds of rocks on the moon. But one thing I find amazing is, according to some recent theories, the moon may have gotten all stuck together really quickly. Initially, they thought maybe over the course of like a month, but now it's even potentially shorter than that. And when you think about the timescales in astronomy, typically being millions or billions of years, the moon getting created in a matter of days just sounds mind-blowing to me.
Right.
Yeah.
Mega volcano. The Earth and the moon used to be molten, and how it solidified.
Yeah.
You know.
Right. And there's more Goldilocks from the moon as well, because the moon, as I understand it, keeps the Earth's tilt relatively stable. And so without the moon, we'd be wobbling all over the place, and that would create sort of more extreme weather conditions. Plus, the moon, of course, creates tides, and we don't know how life began. But one of the theories of life is that it began in tide pools, and that the constant sort of water filling up a little tide pool and then pulling back again and then filling it up again really pushed evolution and natural selection. So without the moon, you wouldn't have tides, and you wouldn't have that driver of life evolving.
Wow, serendipitous, I guess. So why did we just see one side of the moon? Or do we just see one side of the moon?
It's locked, right? So so the moon rotates around the Earth, and right now it only shows us one face, and that's happened over time. That we've ended up it's locked. It's this perfect rotation around the planet.
And that's going to happen to the Earth eventually, right? Like, maybe it will be after the sun's gone, but in principle, the Earth is eventually going to lock and keep the same face towards the sun.
Yeah, there are quite a few exoplanets that we've discovered that are what we call tidally locked with their stars as well. And so they will always have one face facing the star, and one side will always be in the dark. And so typically these planets are quite close to their stars, so it'll be thousands of degrees on the day side all the time, and then very, very cold on the night side.
Well, you mentioned the sun. What kind of star is the sun?
It's a pretty ordinary star. There are stars that are much heavier than the sun, and there are stars that are much lighter than the sun. There are stars that are much younger. There are stars that are much older. So it's halfway through its life. It's a pretty typical mass. It's a pretty typical temperature. While the Earth is pretty special, and I'd be interested in what others say, I would say the sun is perhaps less special, and that we certainly can conceive that you could have life on a planet around a star that's very different from the sun. Would you agree?
But I would say that the fact that the sun is so average is one of the other Goldilocks components, because some stars are very flary. They have a lot more stellar activity, and they're constantly blasting out all this energy in their systems. That would be bad. We get fried all the time. That's like an extinction level event. So we're quite happy to have our average star.
So when you say average, I'm like, as in like, okay, like just mediocre? That's not what you're saying, right?
It's sort of like if you're looking at all the masses and sizes a star can have and temperatures, it's somewhere in the middle. Yeah.
When to the naked eye, when you're looking at the sky, we see so many stars and planets that look like stars. What else in the sky can we see without instruments like telescopes?
Well, the odd comet comes by every once in a while that you can see, and also shooting stars.
Shooting stars.
Which are phenomenal. And scheduled. You can actually plan on your calendar as to when the next shooting stars will come by.
Yeah. Why is that?
Well, you have tails of comets. You have debris from a particular, like the Leonids, a particular cluster. And I look to my other experts to help me out here with examples. But you have your shooting stars that come on schedule because they're meteor showers that are coming.
Yeah, and when you said that, I'm thinking of how we've come to like wish on a shooting star, and where that comes from. I guess
it's a magical experience.
Yeah.
Have you ever been in a really strong meteor shower? If you've never seen it, it's hard to describe how magical it looks. I mean, it's really an incredible experience. And so I can see why you would look at that and think, oh, wow, that's really like magic. I should make a wish.
Are there other planets that within our solar system that we can see without a telescope in the night sky?
Yeah, there are 5 planets total that you can see, the naked eye planets. So Mercury, which is a little bit tough because it's small. Venus, which can get very bright, and you can actually see the phases of Venus, like the moon. You'll have a crescent Venus, depending on where it is on its orbit. Mars, which looks quite red, Jupiter, and Saturn. So those are all the naked eye planets. But the other ones, you have to bust out a telescope to see them.
This has been so amazing. And that wraps up our first discussion on the universe, the cosmos, whatever you want to call it. This has been so fascinating. Tomorrow, we're going to kind of pull out a little bit and talk about the solar system. Thank you so much for your time. We appreciate it.
Thank you.
Our guests all this week are
Bryan Gaensler, Director of the Dunlap Institute for Astronomy and Astrophysics, and Canada Research Chair and Professor at the University of Toronto. Astrophysicist Nathalie Ouellette, who is Deputy Director of the University of Montreal's Trottier Institute for Research on Exoplanets and Outreach Scientist for the James Webb Space Telescope in Canada. Walter Stoddard, Researcher Programmer and longtime science communicator at the Ontario Science Centre. And Matthew Johnson, Associate Professor of Physics and Astronomy at York University and Research Associate Faculty at the Perimeter Institute for Theoretical Physics.